This video is about calculating the lateral area of a cylinder, cone, a sphere, or a hemisphere. So a cylinder is a circular prism and it has circle bases. So the lateral area is your perimeter times height. Remember though, in a circle, your perimeter is going to be the circumference. So it's really 2 pi r times the height. The total surface area then is going to be perimeter times height plus 2 bases. So remember, perimeter is 2 pi r times h plus 2 times the base area, and because it's a circle, our equation is pi r squared. So let's use these equations to find the lateral and total surface area of a cylinder. So number one, we want to find the base area, the lateral area, and the total surface area of the cylinder. The problem is right now, we don't know what the radius of the circle is. So I'm going to draw a diameter in, which creates a right triangle with that 9 and 15. So we can do Pythagorean theorem. 15 squared equals 9 squared plus x squared. 225 is equal to 81 plus x squared. We can subtract 81 from both sides, so 144 equals x squared, which means that x is 12. So if our diameter is 12, it is bisected to have a radius of 6. Now we can find our different areas. So base area, our base area is a circle. So we have pi 6 squared, which would equal 36 pi yards squared. Our lateral area is the perimeter times the height. So perimeter would be 2 pi r, so 2 pi 6 times our height. Our height is the distance between the two bases, which is 9. So 2 times 6 times 9 gets us 108 pi yards squared. For total surface area, we need the lateral area, so 108 pi, plus the area of two bases. And we already know our base is 36 pi. So we get 108 plus 2 times 36, which would get us 180 pi yards squared. Remember, anytime it's a cylinder, you should have pi in your answer because it has a circular base. Number two, a can of soup stands 5 inches high and has a diameter of 3 inches. How much paper is needed to create the label? So remember, if you look at a soup can label, it's only going to be between the two circular lids. So this is really your lateral area that we are trying to find. So the lateral area is perimeter times height. So we have 2 pi times the radius. Well, if the diameter is 3 inches, that means your radius is 1.5. And then we're going to times our height by 5. So in your calculator, you're just going to type 2 times 1.5 times 5, and that gets us 15, and then we put our pi at the end, inches squared. Our next shape is a cone. So a cone is like a pyramid, except for it's going to have a circular base. So to get the lateral area, it's 1/2 perimeter times the slant height, which in this case would be 1/2 times 2 pi r times our slant height. And then the surface area is going to be your lateral area plus 1 base. So it'd be 1/2 times 2 pi r times the slant height plus pi r squared. So in number 3, we want to find the lateral area, but we don't have our slant height yet. Right now, we have our radius and we have the height. To get our slant height, we have to do Pythagorean theorem. So our slant height is equal to 24 squared plus 7 squared. So our slant height is equal to 625, which means our slant height is 25. So to get our lateral area, it's going to be 1/2 times 2 pi r, which is 2 pi times 7, times our slant height of 25. So when we multiply, we're going to put everything in the calculator except for the pi. So 0.5 times 2 times 7 times 25 gets us 175 pi inches squared. In number 4, we want to find the base area, the lateral area, and the surface area. So 30 is going to represent the diameter, which means that our radius is going to be 15. So our base area is just pi 15 squared, which is going to be 225 pi centimeters squared. Our lateral area is going to be 1/2 times 2 pi r, so 2 pi 15 times our slant height of 25. So when we multiply, we get 375 pi centimeters squared. To get our total surface area, we're going to add then our lateral area plus 1 base. So we get 600 pi centimeters squared. In number 5, we have a frustrum. So a frustrum is basically part of it chopped off. The total surface area. So we would wrap around this part here, and then we would also have each circle. So in order to do that, we need to find the total surface area. We need to find the lateral area of a cone as if the cone existed, and then take away the part of the cone that was chopped off. So I'm going to draw that triangle on there, and I'm going to have to use similar figures. So if we have bases that are 7 to 21, we are going to have 7 over 21 equals, we know that this part is 10, but we need to know what this slant height is. So we're going to call that x, and then we have this whole side is x plus 10. So we're going to have x over x plus 10 because we're using similar triangles. When we multiply, we get 21x equals 7x plus 70. So that gets us 14x equals 70. X is 5. So the slant height of the smaller triangle is 5. So we're going to do the lateral area of each cone. So I'm going to do the lateral area of the bigger cone minus the lateral area of the smaller cone. So the bigger cone would be 1/2 times 2 pi r, so 2 pi 21, times our slant height. Well, if this is 5 and this is 10, that slant height would be 15. Then we're going to subtract the lateral area of the smaller cone that got chopped off. So we would have 1/2 times 2 pi 7 times our slant height of 5. And then we need to add each circle base. So on the bottom, we have a circle base that is 21 pi, or 21. So we have pi 21 squared. And then we also have the smaller circle, pi 7 squared. So we get 315 pi minus 35 pi plus 421 pi plus 49 pi. So when we combine that together, we get 770 pi centimeters squared. A sphere is a set of all points in a 3-dimension shape that are equidistant from a center point. The radius is going to be the distance from the center to the sphere. Then we have a great circle. So this circle that's in red over here, that's going to be a circle that contains the diameter, and then a hemisphere is half of a sphere. So now that we have some vocab, we can find the total surface area of both of these figures. So if it is a sphere, our total surface area is 4 pi r squared. Our hemisphere, this is where it gets a little bit tricky for some of us. Yes, it's half of a sphere. So this outside part is going to be the 2 pi r squared. Sometimes I call this a bowl. And then this part over here is going to be that extra pi r squared, which is the circle. Okay, so think about this having a bowl on the outside and then a circle. So if we're going to paint it, it's really 3 pi r squared, but we split it into 2 parts because we don't always use this part when we start getting to composite figures. All right, so in number 6, find the total surface area. So our radius is 18. So we have 4 pi 18 squared. So we're going to do 4 squared. We get 1,296 pi. In number 7, our radius is 24, so we have 2 pi 24 squared plus pi 24 squared. So the first part gets us 1,152 pi plus 576 pi. So when we add those together, we get 1,728 pi centimeters squared. Our last part then, we're going to find the area of a composite figure. So in number 8, we have a cylinder and then a cone on top of it. The total height is 15. Well, if the cylinder is 12, that means the height of the cone is going to be 3. So in this case, when we are looking at this shape, we want the lateral area of the cone plus the lateral area of the cylinder plus we want the area of one circle for the circle that's on the bottom because we're thinking about painting this whole thing. So before we start doing that, the lateral area of the cone, we need to find the slant height. So in order to find the slant height, when we do Pythagorean theorem, we get x squared equals 3 squared plus 6 squared. So we get x squared equals 45, so x is 3 root 5. So our lateral area of the cone is going to be 1/2 2 pi times 6 times 3 root 5 plus the lateral area of the cylinder. So we're going to have the perimeter 2 pi 6 times the height of 12 plus the area of the circle on the bottom. Well, it's going to have the same radius of 6, so it would be pi 6 squared. So we are going to get 18 root 5 pi plus 144 pi plus 36 pi. Now, these two pi's that don't have a root can combine together. So we get 18 root 5 pi plus 180 pi millimeters squared. In number 7, it kind of looks like a pencil. So we have a rounded eraser. This is our hemisphere. We're only talking about the outside part, which is the bowl. That's where we come with that 2 pi r. We have the lateral area of the cylinder, and then we have the lateral area of the cone. So we want the area of the bowl plus the lateral area of the cylinder plus the lateral area of the cone. So if we know this whole thing has a height of 35, this is 16. That's our diameter, which means our radius is 8, which means the radius going this way is also 8 and also 8 over here. Then we know if this is 8, we need to find this height so that we can find the length of the height of the cylinder. So 17 squared equals 8 squared plus x squared. 289 equals 64 plus x squared. 225 equals x squared. X is 15. So if we subtract 8 and 15 from 35, we get that this height is 12. So for our bowl, we're going to do 2 pi radius squared, so 2 pi 8 squared, plus the lateral area of the cylinder is our circumference, 2 pi 8, times the height of the cylinder, which is 12, plus the lateral area of the cone is 1/2 perimeter 2 pi 8 times the slant height of 17. So 15 we're only using to help us find the height of the cylinder. We're not actually using it when we go to solve. So we get 128 pi plus 192 pi plus 136 pi. When we combine those together, we get 456 pi meters squared. Our last part, number 10. A cylinder piece of wood has a radius of 6. There's a 1-inch hole drilled through the center. So the 1-inch hole is going to be the diameter, which means the radius is 0.5. What is the total surface area? So we're missing the height in this picture, so we're just going to call that 14 inches as our height. It didn't get printed on the page, that's okay. So what is the total surface area? So for the total surface area, think about we need to paint this part on the outside and we need to paint this cylinder on the inside, and then we need to worry about our circles. and the part that we drilled the hole through. So the lateral area for the big cylinder is going to be 2 pi 6 times the height of 14. For the inside tube, that's going to be 2 pi 0.5 times 14. Then, if there wasn't a hole drilled, there are two circles. So we have pi 6 squared, but then we want to subtract the little part of the hole that was created by the drill. So we're going to subtract 2 pi 0.5 squared. So we get 168 pi plus 28 pi plus 72 pi minus 0.5 pi. So when we combine those together, we get 267.5 pi, which would be 267.5 pi into square.